In the last lesson, the first construction that we did was to create a segment whose length was equal to the sum of two other segments. In this lesson, we're kind of getting you ready to do that, but since constructing a copy of an angle is a little bit more complicated than constructing the copy of a segment, we're just starting with one angle for right now. So I have this point X, and the instructions want me to use a compass and straight edge to copy angle S where X is. So understand what they mean by that. They haven't told you that X will eventually be the vertex, but that's kind of the point. X will be the vertex of my new angle. I need a side passing through X. So I'm going to move my straight edge to line up with that. And I'm going to draw a ray that starts at X. So that's going to be one of the sides of my angle. My next step is to bring my compass over to the angle that I'm going to be duplicating and put the point of my compass at the vertex of the angle. And I'm not going to open my compass up too much because notice what happens if I do. I'm not going to cross the sides of the angle, and I need to. Okay, so I'm going to squeeze this in just a little bit more, and now I see that I will make a marking on those angles, so that's good. So I'm going to go ahead and make my arc crossing through that angle. And then I take my compass now and duplicate that arc at the copy location. Okay, so what I'm doing is giving myself some reference points on my original angle such that I can set a compass setting that I'm duplicating on my new angle. Here's what I mean. My next compass setting is going to be from here to here. So I take my compass and bring it over to the original angle, and I change my compass setting to be the difference between those 2 points. So it's about there. So there's my compass setting, and then I'm taking that compass setting and bringing it to the intersection of the arc and the ray, and making that arc. And it's very, very important that you realize that in order to do a construction, in order for the construction to be valid, I have to have things intersecting. I can't just draw a line through a random point unless that's the very, very first thing that we're doing. Very frequently, we start with what I call a random ray. Well, that random ray was this thing. That's my random ray. And that's the only random segment that I'm allowed to draw. Now I have a very specific ray that I'm drawing, which goes from this vertex to the intersection of that red arc and black arc. And so now, angle X is the same measure as angle S. In this lesson, we're moving on from segments to start talking about angles. And once again, you know what an angle looks like. If you saw an angle, you would be able to identify it as such. But in geometry, we try to be very, very precise about our definitions. So you see that an angle is defined by two rays having the same endpoint. And we call that endpoint the vertex of the angle, and we call the rays the sides of the angle. There's a couple of different ways that we can name an angle. We can name an angle using a number, if a number is placed inside the angle. We can name an angle using one letter, using just the vertex, or we can name an angle using 3 letters, making sure that the vertex is the middle letter. So again, In your text, example 1 has a part A, and it goes through the entire thought process for you. So you can read that on your time if you wish. Part B has some blanks left for us, so that's what I'll use in this video to talk about angle naming. So in this diagram, the vertex of the angle shown is the point K. So a name for the angle is angle K. The vertex has to be in the middle, so 2 more names for the angle are, and I'm going to put that K down in the middle right out of the gate because I've already said that the vertex must be the letter in the middle. And then it could be LKJ or JKL. It's the exact same angle. Since the angle is numbered, another name for this angle would be angle 1. So take a moment, name angle 2 in this diagram as many different ways as possible. And on your screen, you'll see a couple of choices for what the angle could be named. One of them is correct, and one of them is incorrect. This portion of your text is giving you a little bit of more vocabulary about angles. In this class, we will measure angles primarily using degrees, and there's 360 degrees in a circle. So you see in your text that it says 1 degree is 1/360th of a circle. Again, please notice the difference between how we name an angle and how we notate its measure. Notice the M before the angle sign, M standing for measure. Whereas in the previous screen, we saw just the angle sign. So what is an acute angle? What is an obtuse angle? What is a right angle? What is a straight angle? Make sure that you're aware of these definitions. An acute angle is basically less than 90, of course being positive. In this class, angles are positive. Obtuse angle would be between 90 and 180, and a straight angle is exactly 180. And the next example, again, in your text, example 2 has a part A. It works through the whole thing for you. Rather than talking about that in the video, I'll go through part B of that example all the way through with you. So hopefully you have a protractor to kind of follow along with me as I'm doing it on your screen. So the first thing you want to do is make one of your sides of the angle at 0. So I start at this point on the protractor and I go straight out. And I want an angle measuring 138 degrees. I know that 138 would be an obtuse angle, so I'm not looking at this 138. I'm looking at this one over here. So 138 would be right there. So I kind of put a dot there. Let me make it a little bit bigger so it's easier to see. And then I'm going to make another ray from where my vertex is to where that dot is. And if I move my protractor out of the way, oops, there's my 138 degree angle. This problem is asking us to do the exact opposite, to start with the angle and find its measure. So, get my handy dandy protractor out again. And we're going in the opposite direction. So in the last example, I had you start the ray at this point here on the protractor. I'm putting that point at the vertex of my angle now in order to measure it. And then I'm looking for what number it's passing through, the NM side of the angle, what number it's passing through on my protractor. And once again, it's passing through two numbers, so you have to understand which number you're looking at. Looking at the angle, you would see that it is an acute angle, meaning it is less than 90 degrees, so you're looking at the number that is less than 90 degrees. And that makes it the 40. So the measure of angle N is 40 degrees. In the last lesson on segments, we talked about what a segment bisector is. It's something that passes through the midpoint of a segment. Remember what a midpoint is. It divides a segment into two equal parts. Well, an angle bisector does the same thing for an angle. It divides it into two equal parts. It divides it into two angles having equal measure. Also in the last lesson, we had our first postulate, which was segment addition postulate. Similarly, we have an angle addition postulate. And once again, it should make sense that this part, which is angle PQS, plus this remaining part, which is angle SQR, would equal the whole angle, which is angle PQR. So once again, you'll hear me say that part plus part equals whole. In the last lesson, constructing the bisector of a segment was something that you did by folding paper. In this lesson, we're going to construct the bisector of an angle using a compass and straight edge. I believe your assignment talks about how you would construct the bisector using folding, but we'll get to that later. All right, so bisecting an angle means that my answer is going to be somewhere on my current angle. So I don't need a random ray for this construction. What I do need is kind of a random arc through my angle. And since I'm drawing an arc through the angle, my compass point is on the vertex of the angle. So once again, I'm going to open my compass up so that the markings that I'm making are hitting the sides of that angle. So here's the first marking I make. It's an arc through the angle. And now what I'm looking for is a point that will be as far away from here as it is from here. So that's why I'm going to now move my compass to one of these points and make a marking. And then move it to the other point with the same compass setting, notice, and make another mark. And so notice that these green arcs that I made are crossing here. So from the vertex of my angle to the intersection of those two green arcs, that's my angle bisector. And the instructions ask us to check that the measure of each new angle is 1/2 the measure of the given angle. So that means I need a protractor in order to measure an angle. So I bring my protractor over. In order to measure my angles. So my original angle was approximately 52, and you'll notice that my bisected angle is at about 26. And again, accounting for human error a little bit because my screen is a little bit off, but once again, as I mentioned in the previous lesson, when I test you on this, what I'm looking for are these big sweeping arcs. Notice that red arc. That's an important sign of you knowing the process. The green arcs also. All of these arcs, all of these steps are what I'm looking for.